Let's go through example 3, where a line intersects a circle with a general formula at two distinct points. So they ask you to show this quadratic thing less than 0 in part A. And when you see this, you should think about using discriminant, because using that, you can have a more or less than or equals to 0 situation. And in this equation, there is no x and y, there's only k. So when the x and y are not there, it's just one of like a alphabet like k, or what else? A, B, those kind. There's no x and y's, then we can think about discriminant, because when we use discriminant d squared minus 4ac, we do not take the x and y's. We only take their coefficients. So first thing, we will sub in the line into the circle. Okay, let's do that. X squared minus 10x minus 12 kx plus 57 equals 0. X squared plus k squared x squared. Okay, so to identify what is the A, B, and C here first, the A is the coefficient for x squared. So we have x squares like these two here. We just take their numbers in the front. So the first one is like 1, and then the other one is k squared. So I add them. Then for B, it is minus 10, minus 12k, and C is 57. Okay. So discriminant is b squared minus 4ac. So b is this minus 4a, and the c. Okay, for the b square, they are both negative. So you can change both to positive, because if you square whatever's inside, the negatives will turn positive anyway. So you can look at it as a 10 plus 12k squared. And then here, the number 4, it only multiplies into one of the brackets, so cannot be for both brackets. So I can multiply to the one beside it, so it will turn into 4 plus 4k squared. Okay, expand this, 12 times 2, 144k squared. Okay, 4 times 57. 228. 228 for that, and then the negative also goes in, so we get negative 228k squared. Okay, then simplify. 144 minus 228, negative 84. K squared. Okay, and then plus 240k. And then 100 minus 228. Get minus 128. Okay, so because they cut at two distinct points, that means the discriminant is more than 0. So you can let this be more than 0. But I want to get it to a 21k squared. 21k squared. So I need to divide everything here by a negative 4. Negative 4, I can get 21k squared. Okay, 240 divided by negative 4.
How can I help?
Minus 60.
Call me again when you are ready.
Oh. Sorry, that's my massage chair talking. Minus 2. This becomes plus 32. So because you divide by negative 4, the more than sign also changes into a less than sign. Divided, yeah. And then it will look like the part A. Okay, so that shown. Find the range of possible k values. So we need to solve this. How you do it is, let me see. We need to, it's a quadratic. It's a positive happy face quadratic. Then you need to find the two intersections. And it's a less than 0. That means I want the part of the curve that is below the x-axis. So we use a calculator again to calculate out what are the two intersection. -21 minus 60 and 32. Okay, boo, but they are decimals. Let me check. Part A is correct. Okay, try again. 21 minus 60 and 32. Yeah, okay, they are decimals. So, okay, I can still do decimals because they just say find the range of possible k values. Or do I? It's better if I find the exact number. So if I do the quadratic formula, then it's like the b minus b plus minus square root b squared minus 4 ac out of 2a. Okay. So just typing what's in the square root first, times, because that's the one that's making it into a decimal. 60 squared minus, okay, so we get 60 plus minus square root 912 out of 42. 912. 912 I can divide by 16. So 912 I can divide by 16. That means it can split into a square root 16 and a square root 57. That, because 16 and 57 gives me back 912. So a square root 16 and square root 57. 2, 60 out of 42. 10 over 7 plus minus. 6 square root 16 is 4. So 4 out of 42 is 2 out of 21 square root 57. It's not. So these are the values that are the intercept. This one is the plus. And this side is the minus. Okay, so to be in that region, then we need to choose the range. 10 over 7 minus that is less than, let me think, the k here. So k is between these two values, basically. Yeah, that's the answer for the part B. Okay, next one is about tangent and chords to a circle. So if you have a line that is touching the circle at just one point on the outside, it is called a tangent. And if you connect the radius from the center go to the tangent, it's right angle. And then if you have a chord is any like a line segment inside the circle that is not a diameter, like it must touch both ends of the circle, that's a chord. And then if you have a bisector of that chord, it will run through the center of the circle. Yeah, because it's symmetrical. From the chord, you draw a right angle bisector line up, then you'll get the center. So if you have a circle here with the standard equation, they want you to verify that this point. So how you verify again is you sub in like the x value. So then you see if you get the y value to be 0. So let's try. So if I sub x equals to 10, we need to see if we can get y to be 0. This will be 8 squared, so 64. Then this one, okay, this one don't open. Leave it in the bracket. Then I just square root the other side. Y minus 6 squared equals to 36. Yeah, so the 64 minus to the 100. Then y minus 6 equals to plus minus square root of a 36. Okay, so y equals to plus minus 6 plus 6. That is 12, or minus 6 plus 6, 0. Okay, so again, we get y, it does equal to 0, but it also gives you to y is a 12. That means when x is 10, it will cut the circle at those 2 points. Yeah, so like when x is 10, let's say like here, then you see it cuts one on top, one below. So probably the below one is 0, then the y value on top is 12. Okay, find the equation of the tangent to the point, to the circle at point P. So at P is the 10, 0. Let's say we put it here. P, 10, 0. And I want to have a tangent there, so like a line that cuts through there. Yeah, it needs to be touching the circle at one point. So center of the circle in this case, you can see it's a 2 and 6. So I'm gonna write 2 and 6 here. And I want it to connect to that point P. That will be the radius. Okay. To get the equation of the tangent line, I need the gradient. So I use the radius gradient to find the tangent line gradient. So the radius, let me find the gradient first. So the y value is 0 minus 6 out of 10 minus 2. Then it will be minus 6 out of 8 equals minus 3 over 4. Okay, so then the gradient of the tangent, the line, gradient of tangent is a negative 1 out of the gradient of the radius. So just use calculator and you will get positive 4 out of 3. Basically, it's a flip of the fraction. Then that's your gradient for this line over 3. So now I need to come up with the equation. Equation is y equals to 4 over 3x plus c. And that point on the line is P. So the 10 and the 0, I can sub it in. Sub P inside. So then the y is 0. And then the x is 10. So we can find C, negative 40 over 3. Okay, so that's your equation for the tangent. Therefore, y equals 4 over 3x minus 40 over 3. Okay. Okay. Next example is slightly longer. So in here we have a diagram, and okay, we need to see there's a chord, there's a center, midpoint, there's a line L. Okay. The line K, okay, the line pass through M and C. Find equation for the line. Okay, so you need to find the gradient and one point on the line to be able to do this. So we need to find gradient first. Gradient of the chord PQ. PQ is -1 minus -5. Out of -7 minus 3. So that's the y minus y over x minus x. Then you're getting 4 over minus 10. So it is 2, -2 out of 5. Which means the gradient of the line K is 5 over 2. So you can just flip it and change negative to positive. Then we need the center. We don't have center. Okay, then we find the midpoint. Midpoint, the M, is the x values, add up, and then divide 2. Then y value, add up. Be careful of the plus and then -5. Must remember to put minus. Then divide 2. So the midpoint is minus 4 over 2 minus 2 and -6 over 2 minus 3. So we have the gradient, we have the 1 point on the line. So you can sub it into the equation. Equation of the line will be y equals 5 over 2x plus c. And we sub m inside. Then you get -3 equals 5 over 2. X sub in is -2 plus c. Okay, so then it's -3 plus 10 over 2 equals c. So type that in. So c is 2. Okay, so the line is y equals 5 over 2x plus 2. Okay, that. So next one is the y coordinate of c is -8. That means at this level, to the y-axis is -8. Show that the x coordinate of c is -4. Okay, so c is on this line. So I can sub in the y to be -8 and then I find the x. All right, B. This one is part A. So sub y equals to -8. Then we find x. That will be -4. Yes. Okay. So then yes, you got this. You got -4. You show to them. Now find the equation of the circle. So the circle center is this -4 and -8. Now all I need is the radius. Radius. How am I gonna find that? Radius. Okay, we can find from the center, go to example P. That will be the radius. Because I cannot find this one. So I go to 1 point on the circumference. So let's do that. So the radius is the distance formula. So square root minus 4, because the center is minus 4. Let me write here. Minus. Okay, so yeah, that's the x minus x. Oh wait, I need another bracket. This one is minus 7, and then I must bracket square plus minus 8 minus 1 square. No, I must bracket first. Square. Yeah, then the whole thing square root. So maybe I don't type the square root first, I type what's inside the square root. Square. Okay, in the square root is 58. Okay, radius. So I got the center, so I can do center. The x value is minus 4, so it will be a plus 4 here. Then plus y value is the minus 8, so I'll do plus 8 here. And then here must be radius square, so that is like square root 58 square. So that will be just 58. Because the square remove the square root. Okay. Okay, this last part of the chapter is on triangle and circles. So if you have a right angled triangle in a circle that touches all the circumference corners, then the A to B, the longest length, will be the diameter. So example here is there is a triangle in the circle and they're asking you to find whether AB is the diameter. So what you do here is you have to prove that it's a right angle triangle using Pythagoras theorem. So you can see from here, you can see from here, they have to do the Pythagoras theorem like one side of it. And then with the length formula, you can find the sides and then you will get 160. Because also the squares here will remove the square roots. Yeah. So then you just get this whole number. Then AB square also, that is the diameter, which we also get 160. So therefore it is the right angle triangle. By converse of Pythagoras theorem, we can write this. You can write them together now because they have proven to be the same value. And then ABC is a right angled triangle, and so therefore AB is the diameter. Then part B. Part B is to find equation of the circle. So we need the center point and we also need the radius. So from AB square, we got 160 just now. Here. So that means if I square root AB, if I square root the 160, I mean, you will get AB. Then when that's diameter, so the radius will be half of that. So there's a divide 2. And then in part B, we have to find the midpoint of A to B to get the center. So the center is again using the x values and the y values. You add them up and you divide by 2. You will get the minus 2 and 3. Okay, and then we just need to write out the equation. So you plug in the center into the front 2 brackets and then equals to r square. So radius square, when you type in calculator, you just get a 40. Yeah, so that's it for the chapter 2.